Pharmacogenomics is a scary word, but really it's easy. Pharmaco, like pharmacology, drugs. Genomics, like genes. Pharmacogenomics is the study of how your genes affect how you respond to drugs. I'm chair of bioengineering. Steve Quake is the co-chair. We work very closely together on a number of issues. One of the things we work together very closely on is our mutual commitment to the future of medicine as personalized medicine.
I met Russ Altman when we came together to lead the Department of Bioengineering, and we realized that we had overlapping research interests in this area.
We take two different approaches. Steve is a biotechnologist. He develops amazing new technologies, mostly very high throughput, very small scale measurement technologies.
He's a physician, so he's kind of on the practicing end of this business, and realized that he'd like his patients to respond better to the things he prescribed. And one of the things we're spending a lot of time on these days is personalized genomic health.
You inherit your response to drugs just like you inherit your hair color and your height.
This has all sort of been studied at a population level. The advent of new DNA sequencing technologies are now making it possible for each person to have their own genome sequenced. All of a sudden, this information becomes a lot more personal.
What is it about your genome that we can use to prescribe medications more accurately, to avoid side effects, and make sure that your response is most efficacious as possible?
This machine here is what we use to sequence human genomes. It's the world's fastest DNA sequencer. And it is actually the fruit of something that started off as a very basic science experiment in my lab. That led us to develop the first single molecule DNA sequencing techniques, and it eventually got spun out into a company that makes these machines. And now we in turn use them to ask basic questions about human genetic variation.
The future vision for pharmacogenomics is very simple. We sequence the genome of the patient, we put it in a database. Every time the doctor needs to make a prescribing decision about drugs, they go to an information system that says, given this patient's genetic background, stay away from these drugs, but go ahead and use these and try them at the following dose. Because drugs are designed on a one-size-fits-all basis, but one size does not fit all.
In fact, I'm one of the first guinea pigs of this project, and we sequenced my genome last month and are in the stages of assembling it right now. And I'm hoping very soon to be able to ask some of these questions about my own life.